We have this, applications on this, and one more small unit of 4 days. And then we're done with your whole course. So hang in there. Okay, you can. Okay, again, this one, we start with your x equation. We solve it for t in terms of x. We want to eliminate the parameter, which is your t variable. So we solve it for t. It's not so pretty looking, that's okay. We plug it in. We work this out, and we say, okay, and that it doesn't matter if you find a common denominator first and then do the numerator, find a common denominator last. I just distributed this, and then I found a common denominator. Would it be better to find a common denominator and then distribute it? That's up to you. Either way you want to do it is fine. Just reduce it. If you look at this, this is your slope. This is your y-intercept. There's a line. And the equation we got from this was a line. It was a line that passed through the 5/3. It went this way. Now, when you did this and we put the table out there, if you put this in your y equal, and you go to your table of your x and y's, it'll be the same x and y's that you had. Now, yesterday we said, not always do those x's show up because of the way we did our t-step. If you do a calc value, you can pick an x, put it in as a value, and see that it matches the y. I should have put the table out here as well, because that would probably make more sense. Let me pull up my homework. Alright, so you had a table with x's and y's here. Just like real briefly, you had a t, you had an x, you had a y. So we did this. These guys are your x-y pairs. If you graph this in your calculator and you look at these values of x, you will find that value of y. So it's eliminating your parameters to make us a rectangular equation. We start with the x. The reason we start with the x and put it into the y is because it sets us up for y equals. Okay? And so it's a little bit more helpful to do it that way. Did we do this one together yesterday? Yeah, we did this one together. Okay, so let's move on. Some of the other ones are a little bit easier. Okay, this one, you take the x one. Watch. Okay, I want to get rid of this fraction. Multiply both sides by 4. Get rid of your fraction. Cancel it out, and you're left with 4x equals t. Well, this is what we wanted. We wanted to solve for t. So now, we go to your y equation, and in place of t, we substitute in 4x. But this has to get squared. So raised to the power 16x squared. And on your graph, you saw that this was a parabola that looked like this. And this is a parabola that opens up. A little dilation of a little stretch in there. But if you checked your x and your y, now this one, when we did it, our x's were very small. So watch. For instance, this was -5, this x was -1.25, and this y was 25. Now, when you go to graph this, and your y equals, your table is probably incremented by 1. It doesn't contain this number. So therefore, in your y equals, you're going to do second calc, number 1, for value. And you're going to plug in this x value. And you're going to see that y value returned. Because it's not going to show up in your table, because your table was incremented by 1. Start at 0, increment by 1. So just do a calc value on a couple of them, so that you could see that they're there. Okay, sometimes we have a little rounding going on, but this one should probably work. Just so that you can kind of eliminate your parameters to see what the graph looks like. And that's really all we did. We worked with the same homework from the day before. Now, this one's nice, because we're here, you want to solve for t. Well, a square, you take a square root, so a cube, you take a cube root. So your cube root from both sides, so that if you did this, take the cube root of both sides, that comes out, so your t is equal to the cube root of x. If you wanted to write it x to the 1/3, maybe that looks a little better. You can write it x to the 1/3. You're going to plug it in for this t. So therefore, maybe to the 1/3 is a little bit nicer. Remember, we put the one inside on top here, and then the guy outside on the bottom. When you plug it into that t, raised to the 2, there's your x to the 2/3. It's a weird looking thing, but it still gave us a parabola, and we could still check it on your calculator. Okay? Was that it? All right. It must be shrinking. I didn't give you these. All right. So we're going to start with a couple of these. We're going to start with a couple of these guys together. All right. You're not going to fail this test. I didn't even give you a test yet. Remember, I have it written here. Terrible eyesight. All right. Now, what's our parameter in this? You don't have it, so you have to write this down. You don't have it. Where's the parameter, Chris? Yeah, what would our parameter be? We did this yesterday with the sine squared plus cosine squared. This angle. The angle. That's going to be your parameter. Now, okay, pull up, get your calculators handy. Get your calculators handy. Let's see what this guy looks like.
What was it? Y equals 2 cosine what?
Y equals 2 cosine 2 theta. And x equals 4 cosine, I'm sorry, 4 sine 2 theta. That's the parameter. So as soon as you go hit that theta sign with your parameters, it'll be a t. Yeah, you see where your x, your parameter, your x, your t, your angle? Hit that up there because it's really your t. Okay. All right, so let's put this in. I have 4 sine 2 theta, and as soon as you hit this, that's your t, that's your parameter. And I have 2 cosine 2 theta. Okay. Now yesterday we changed this. We changed your t-step. Whenever you're dealing with an angle, your maximum angles are 360, right? We can go from 0 to 360. So we're letting our t-step go from 0 to 360. I put the t-step at 5. It's small. I'm going to raise it to 30. But the reason I put it at 5 is it goes a little slower so you could watch this graph. And then we'll change it to 30. My X-min and my X-max, they probably don't have to be this large. Make this just be, let's say, let's just do -5 to +5 for both of these. Okay? Now, watch the graph. Your OPS, your mode has to say degrees. Because we're working.
Where's start?
Yeah, go to your mode. Hit your mode button. It has to be in degrees. Radians will force this thing to go crazy. So now, watch. Watch up here. Look where it started. See it start up here and went there? There's your ellipse. This is an equation of an ellipse. Now, we were never able to graph an ellipse before. So it started it right here. Your orientation follows the path that it goes, the direction. It goes this way. And it comes back and it meets right here. Didn't it travel 360 degrees? Right? Now watch something interesting. If I go to my window and I change my T-step, let's say I just go 300. When I graph this, look what happens. Look. Oh, usually, it must have a double cycle. It has a double cycle because it's a double angle. Let me change this to, yeah, because of your T-step. You can change your T-step, and make it a little bit higher.
How do I make it stop moving?
See, I stopped. How do you make it stop moving?
Yeah.
Sorry. Oh, see, look for your T-step.
Yeah, it was small.
Yeah, you have to raise it. Even 20 degrees is better.
Why did you
Okay.
stop?
Well, actually, it's a double angle, so the cycle is twice. So really, 180 is one cycle. Another 180 is another cycle. So I cut it to 160 to show you that it stops. If your T-step is not long enough, it will stop. Unfortunately, this was a double angle, so it had half the cycle. So it wasn't my 360 guy up here. Now, when we do this, we get your ellipse. And it graphs like your ellipse graphs, like this. And here's your orientation. It started at here. So this is where your angle was 0. So your angle of 0, your sine at 0 is 0. Times 4 is 0, right? Your cosine at 0 is 1. Times 2 is 2. So you see this point? 0, 2. There you are on a rectangular plane. Okay, so now your angles are going around, and they're making your x, y points for this. Using parametrics, we can graph something that's not a function. Now we're going to eliminate this. So we're going to solve for the parameter. We're just going to consider 2 theta as one angle. Oh, there's it outside? Oh. All right, let's divide by 4. I thought somebody was like frying or something. And 2 cosine 2 theta. So let's divide this by 2. Okay, now we're going to consider your cosine 2 theta as one angle, as just a regular angle. And we're going to make this now for our one identity that we remembered, and that's this. So we're going to consider this as one angle. So we're going to substitute in. We're going to substitute in your x over 4. We're going to substitute in your y over 2. And we're going to do the square for this. X squared over 16 plus y squared over 4. And this is our rectangular equation for this ellipse, right? What's the major axis of this ellipse? Who's bigger? X, this is the major axis. So what is A equal to? 4. This is your minor. What is B equal to? 2. Oh, look, didn't we say 0, 2 on that, right? What's your center at? 0, 0. So we took a parametric of your ellipse, we eliminated the parameter, and made your ellipse equation. This is called our rectangular equation. Why? Because it lives on your coordinate grid with your x and your y's. We're not able to graph this in one statement in your calculator. We would have to solve for y squared, then take the square root and put in 2 statements. But with the parametric, we can do this all at once. Yes. The 0, 2, because we made our t go from 0 to 360. This is our starting point when t, or this angle, is equal to 0. So we said the sine at 0 starts here, right, is 0. So 0 times 4 the x value would be 0. Then we did the cosine. The cosine of 0 starts up here, so it's 1. And 1 times 2, the y value would be 2. Rather than pull it off your table, I just did it by hand. So here's your coordinate point, 0, 2. Okay, so there's your starting point. So I just wanted you to see that it'll match up to your ellipse. Okay? So we're going to use your parametrics, eliminate your parameter, and solve for a rectangular equation. Good? All right. Let's try another one. Getting it? Not so bad, right? You can almost kind of see what's happening. Eyeball this one for me. Yeah, eyeball this one. Yeah, 19. What does it look like it's going to be? No, number 19. Number 19. What does it look like it's going to be? It looks like it's going to be an ellipse. Is the center going to be 0, 0? No. You said ellipse because you saw the plus sign, right, with the cosine squared plus sine squared. And it's not at 0, 0 because what do we have to do first? We have to move this over. So we have to solve for this. This is where your parameter is, right here. So subtract 4. So that looks nice. Now, do the y. Add 1. There's one identity that you always have to remember. Aaron? Oh, it's 2 cosine. Thank you. So therefore, I'm going to have to divide by, oh, and I missed this negative, oh, I got the negative one. I have to divide by 2, right? Thank you. Okay, so therefore now, I have my cosine and I have my sine. All right, so my one identity. Does it matter what order I write this in? No. In ellipse, I can go either way. In a hyperbola, if one of those was negative, I'll find out as soon as I put it in there, and then I can just swap them back out. So I substitute in. Don't forget, this thing is being squared, plus my sine. Since it doesn't have a denominator, is it okay with you if I put it over 1? So we can see, so that it matches up to your ellipse? I know Jada says yes, of course. So now, we raise to the power. 3 squared, 4. Here's the equation of my ellipse. Which one is the major axis? The x or the y? The x. So this is a squared, so a is 2. What's b? Square root of this, 1. What's my center?
4.
Good. 4, negative 1. So let's write this here. A is 2, b is 1, my center is 4, negative 1. Let's put this guy in your parametrics. And let's see what it looks like. You said this x is my major axis, so I should see it horizontally oblong, right? Let's go back to your y equals. So we're going to plug in your first one, 4 plus 2 cosine. There's your parameter. And then your second one says negative 1 plus sine. There's your parameter. And remember, I changed my window, so I'm just going to go back and change this to 360. If you want to change your t-step a little higher, it'll go a little faster when you graph. I kind of like it slow, only because this way you can kind of watch it graph. Now, I'm going to have to change my x because, remember, this is shifting over. It's going to start at 4, negative 1. And then I'm going to add some to the sides. So I'm just going to make this go negative 10 to negative 10. I'm negative 10 to positive 10 for both of them. And if it doesn't work, I go to my table and I see what will work. So I graph. There's my ellipse. It started right here. See it? It started right here. And it went around like this. There's my ellipse. Does my center look like it's approximately 4, 1? Yeah? Does B look like it's 1? Because I wrote over it. 4, negative 1. So See my center? 1, 2, 3, 4, negative 1. My B is 1. And from here to the outside, there's my 2, right? There's my 2. Yes.
Mine went the opposite.
What do you mean it started and it went this way?
Yeah, it went the opposite.
Really? Okay. I'll take a look at it. Okay, move on. Take a look at it. While we're doing, continue with the circle. Okay. Now, the circle, normally your circle formula is going to look like this. Plus y squared, no denominator. Or they could be offset. If it's offset, which it will be. So first thing I want you to do is plug these pieces in. This is your HK, that's your R. HKR. Plug those in. So X is going to be equal to 2 plus 4 cosine theta. See what I did? H here, R here. Good? And Y is going to be equal to 1 plus 4 sine theta.
So then you just solve it before.
Just like we did. Same thing. So now we subtract 2. Divide by 4. Subtract 1. Divide by 4. Do you notice that both of your denominators are the same? So that kind of points us that we have a special ellipse, which would be a circle. So now, cosine squared plus sine squared equals 1. So your cosine is x minus 2 over 4 squared plus y minus 1 over 4 squared. And just distribute this part. Leave the top with your x minus 2, that's your x minus h. Y minus 1, leave it the y minus k. Now the last step we need to do, since this is an ellipse with a special condition that makes it a circle, multiply through by 16. Here's your equation of your circle. Right? We just want to make it look like the r squared thing. You can probably leave it as an ellipse, it's not wrong, but if we want the circle formula, then get rid of the denominator. Okay? Questions? All right.